Send the answers on my WhatsApp. Okay, Rafat. So yeah, first one is fine, second one is fine. Yeah, third one is also fine. Good. Yes, now also the first one is okay. Second one, yeah, okay. Yeah, correct. And the third one is also fine. Yeah, very good. Okay. So you've got the concepts. In the last class, we ended up talking about the electrode potentials, and we also talked about what did I do in the last class. So E naught is independent of shape, and okay, fine. And standard electrode potential is intensive property. Okay. Also SOP and SRP, we have these things. Okay, we're talking about electrode potential in general only, right? Electrode potential in general. Okay. Now, this concept of electrode potential is quite important. It is very important that you have an intuitive idea about it. What is this electrode potential? So I am, okay. You must have your NCERT textbook right now. If not, then can you please take out the NCERT textbook? And then in the NCERT, go to page number, just a second. You go to page number, what is this, 71. You'll see a very large table there. Is everyone there? Yes, tell me.
Yes.
Okay. What I can do is I can also take this table and paste it here. Like, do a quick scan of all of these values here. I don't think so. That's the size I should enlarge the size of this thing. Like, for example, what is happening? First of all, you have to think in the terms of, is it reduction or oxidation? What is happening here? The first one for fluorine. Reduction or oxidation, please tell me. It is losing electron or is it gaining electron? Start with fluorine here and look at fluorine here. Gaining electron or losing electron?
Reduction.
Reduction, right? Nawal, tell me.
Reduction.
Reduction, right? Okay, fine. And with this reduction, it is giving me electricity or it is needing electricity? Tell me. It is giving me electricity or is it needing electricity? When this reduction happens, it gives me electricity or it needs electricity?
It needs electricity.
It needs electricity. Why? Tell me. Why does it need electricity?
Because it's not spontaneous.
No. I mean, how can you say it is not spontaneous? Like this value here. Okay, so can I say something like that? If I have this reaction happening and I add a voltmeter here, then what will be the reading of the voltmeter? Tell me. If I add a voltmeter and this reaction is happening, what will be the reading of voltmeter?
2.87.
2.87. Then what does it mean? Is this giving me electricity or it is taking electricity? What do you guys think? Giving or taking? I hope you guys know how a voltmeter functions, right? Yes or no?
So,
Tell me.
it's taking.
It's taking electricity. So that means if I will add a voltmeter, then it will not show any reading, right? If you're saying, because voltmeter to battery ka hota hai, correct? Volts you
Yes.
talk about batteries, right? And if a battery has 5 volts, then what does it mean? Does battery need electricity or it gives electricity? It gives electricity, right? So what it gives, right? So you have to understand these are like batteries. These are like batteries. So whenever we have a positive value here, then this reaction here, that means the reduction of fluorine, the reduction, that means fluorine is eating up electron and it is going to give electricity. Also, please think in those terms now. Think in that term. Fluorine, it will automatically eat up electrons, right? Because it is very electronegative. Its electron gain enthalpy is very high, correct? I hope you remember from periodic properties now. Right? It will readily eat up electrons, correct? Yes or no?
Yes.
Right. So obviously it is going to be spontaneous, and that is why we are getting what? The electricity. All of you understood this? Yes or no? Tell me. Rifat and Nawal,
Yes.
both of you?
Yes, sir.
Okay, fine. Now, when we have, now you will see very interestingly, what is this lithium? Lithium is a metal or non-metal? Lithium is a metal or non-metal? Tell me. Rifat, your why is that? Can you please keep your mic on, Rifat? Tell me whether it is a metal or non-metal. Please don't turn it off.
Metal.
So what you have to do, Rifat, you have to keep your mic on for a longer time. I cannot hear otherwise. Okay. So I think
Yes.
you're using space bar for turning the mic on and off.
Yes.
So that is why there is some problem. Okay. So like even if you're using space bar, then please press it for a longer time. Otherwise, I just get those kind of on nothing else. Okay. So lithium is a metal. So obviously it will, now this negative sign, it represents what? It needs electricity for this reaction to happen. Correct? Yes or no? Tell me.
Yes. Yes.
Right. But if I write the opposite of this reaction, lithium giving me lithium positive plus electron. Now this is going to be spontaneous because lithium is a metal and metal has a tendency to lose electron. So this is going to be plus 3.05 volts. It is going to give me how many volts of energy? Plus 3.05. You got an idea? Yes or no? Please tell me.
Yes. Yes.
Right. And also you can see that most of the things that you are seeing here, which are having negative values, that means it requires energy. All of these things are going to be metal. See, all of these are metals, right? Here we have H2. We'll talk about that H2O, why we have H2O here. Then we have metal, metal, metal. Each and everything is metal. Can you see that? Yes or no? Please tell me.
Yes.
Yes, sir.
Right. So all of these things which are negative, that means metals, they don't eat up electron easily. That is why all of these things are negative. That means we have to give energy. Now, let us look at this reaction that we have been seeing for a very long time. Where is this reaction? Zn plus 2 electron. We have seen the opposite of this reaction, right? And then we had a cell in which we had copper. So these two reactions, let us look at these two reactions. Copper and zinc. So for zinc, they have written zinc 2 plus 2 electron. Can you read it from your textbook? What is the value? This is how much? What happened? Giving me zinc. What is the value here?
0.
0.07.
07.
76 ना? ठीक से तो देखिए. 76 ना? 0.7.
0.76.
Yeah, 0.76. Okay, fine. And for copper, tell me, copper 2 plus 2 electron.
0.34.
Okay, this is going to give you. This was minus. Okay, sorry, this was plus. Am I right with the signs? Please tell me, yes or no?
Yes.
Yes.
Okay, fine. Now you tell me, which of the following, zinc or copper, which would easily do reduction? Spontaneous reduction कहाँ पे हो रहा है? Copper का हो रहा है, zinc का हो रहा है? Tell me.
Zinc.
Nawal, can you please repeat 10 times for me? If it is spontaneous, it will have positive volt. Tell me, Nawal. I told you right now, na? If it is spontaneous, it will give me electricity. If it is giving electricity, then it is going to be having positive volts. Tell me, repeat it. Turn your mic on.
It's spontaneous. It's going to have positive.
If it is no, not what positive? Positive,
Charge.
not charge. Positive volts, electricity, volts, E naught, potential, positive potential. Please tell me, Nawal, once again. If it is spontaneous, it will have positive volts. The complete sentence.
If it's spontaneous, then it will have positive.
Okay. Now tell me, who is happy for reduction? Copper or zinc? Who is happy for reduction? Where is it spontaneous?
Copper.
Copper is spontaneous and it is doing reduction. So that means we will prefer this on the anode or cathode. We'll do this reaction on anode or cathode if it is reduction and it is doing happily. Very good. Rifat, आपको आ रहा है? Yes or no? Okay. And tell me, is zinc doing reduction happily? Is zinc doing reduction happily?
No.
No. That means what we have to do, we will reverse this reaction. So if I write this, zinc is giving me zinc 2 plus 2 electron. This reaction will now give me 0.76 volts. Yes or no? Please tell me. Correct?
Yes.
Okay. Now, this is going to be your what? Anode. Correct? Is this clear? Yes or no? Please tell me.
Yes.
Yes.
Sir.
Okay, fine. No. Please keep your mic on and tell me. We have a cell in which the first reaction is happening. We have a cell in which first and second both the reactions are happening. Yes or no? Please tell me. Both the reactions were happening. Correct?
Yes.
That means that complete cell, the E naught of cell, the complete cell will give me 0.34 plus 0.76 volts of energy. Is that clear? Yes or no? Please tell me.
Yes.
Yes,
I hope there is no difficulty in understanding this.
No, sir.
Right? Now, if you have been learning electrochemistry in school, you must have seen this type of formula that if you have E naught cell, then it is going to be what? Then it is going to be E of cathode minus E of anode, right? Okay. Now, this did not particularly make sense to me. So I figured out what is happening. Why do we have a minus sign? So what I figured out was there were two reactions. And in one of the cases, see, in both of the cases here, E naught and E naught, they are taking just the reduction potential. But what we are going to do, we are going to write E naught cell is equal to E naught of oxidation plus E naught of reduction. Oxidation means oxidation potential of whom? जिसका oxidation हो रहा है ना, whatever is in anode. And E naught reduction of whose? Whatever is in cathode. As you can see here, we have not taken the E naught for E naught. That means standard electrode potential is reduction potential. If you remember from last class, the E naught of a particular thing, it is what? E naught reduction only. Okay. If I write E naught, that means it is E naught reduction. And all of these values, you have seen that it is what? It is reduction potentials. All of these values that IUPAC gives us is reduction potential. Okay. But simply what you have to do, you don't have to worry about all of these things. You just have to write E naught cell is equal to E naught of oxidation, whose oxidation, whatever is in anode, E naught of reduction, whose reduction, whatever is in cathode. Is that clear? Yes or no? Please tell me.
Yes, sir.
Okay, fine. Now you'll write. First of all, write two terms, oxidation potential and reduction potential. The tendency of an electrode, the tendency of an electrode to lose electron, that means to get oxidized, to lose electron, or we can write or to get oxidized, is called oxidation potential. Higher the value of oxidation potential, higher is the tendency to lose electron. Reduction potential. There is no difference, same definition here, the tendency of an electrode to gain electron. Or to get reduced. It's called reduction potential. Nawal, if it is spontaneous, it will have positive volts or negative volts. Nawal,
Yes.
very good. Higher the value of Rp, higher is the tendency to gain electron or to get reduced. Okay. Then all of you know, please tell me.
Done, sir.
Wrote these two. Okay. Now write next point. Galvanic cell consists of two half cells जिसमें ऑक्सीडेशन हो रहा है और एक में रिडक्शन हो रहा है, राइट? The half cell having higher reduction potential behaves as, कैसा बिहेव करेगा बताइए? एनोड या कैथोड? behaves as, if it is having higher reduction potential then it will behave as, very good. देखिए आप लोग को आता है ना, सी देखिए पहले ही क्लास में हमने सब कुछ इस तरह से पढ़ा दिया कि आप लोग आगे के आंसर देने लगे, ठीक है? going to be कैथोड. The half cell having higher oxidation potential will act as anode.
Sir,
Hmm.
is the Daniel cell and galvanic cell same thing?
What? Sorry.
Daniel cell and galvanic cell.
Daniel cell and galvanic cell. No.
Yes.
Daniel cell is a specific type. Galvanic cell and electrochemical cell are same. Okay. Fine. Galvanic
Yes.
cell and electrochemical cell are same. Daniel cell is that cell in which we are using zinc and copper. The cell which we learned now. Okay. So galvanic cell is all type of electrochemical cell. One of the specific type of galvanic cell is a what? It is a Daniel cell. So Daniel cell is a galvanic cell, is not the galvanic cell. Got it? Yes or no? Tell me.
Yes, sir.
Okay. Fine. Just give me a second. I will give you some questions. Okay. Okay, we have the standard electrode potential. Forget about the question, what they are asking. Okay? Given the standard electrode potential, you have to tell me what is happening here? Reduction or oxidation? This is first cell, this is second cell, and this is third cell. Tell me what is happening here? Reduction or oxidation? K+2K क्या हो रहा है? अरे, what happened, guys? Tell me.
Reduction.
थोड़ा loudly.
Reduction.
Reduction. Rifat, you agree? Reduction.
Yes, sir.
Okay, and here? What is happening here?
Oxidation.
अरे भाई देख के
Reduction.
रिडक्शन ही हो रहा है ना रिफत, ध्यान से देखिए कहाँ देख रहे हैं आप? हाँ,
Yes, sir.
कैसे रिडक्शन हो रहा है बताइए रिफत? व्हाई इज इट रिडक्शन? सॉरी,
Sir, I'm confused.
हाँ, तो आपको नहीं पता बोलिए ना, आप ऐसे क्यों हाँ में हाँ मिलाते चली जाती हैं बस. ओके, व्हाट इज रिडक्शन, टेल मी.
So when it is
Sorry.
when it gains an electron,
Rifat, if you are using earphone and all, like, can you please fix? It's very noisy. Nawal, is that me or can you hear also some noise disturbance kind of thing? Yes, Nawal.
No, I don't.
दोनों ही का माइक एकदम ही अजीब है. Okay, Rifat, tell me, what do you understand by reduction?
when it loses and gains an electron.
Right, correct. Or or there is a decrease in oxidation state, correct?
Yes.
Okay. So oxidation and reduction, these are only related to electrons. Are you confused by these values?
Yes.
Like, no, you have to not look at value. When I say oxidation and reduction, then where you have to look? You have to look here. Here. Okay, the values, the numbers, they don't matter, na, because electrons hai wahan pe, theek hai? So the electrons are going here and electrons are going there. Correct? Yes or no? Please tell me.
Yes.
Okay, fine. So now you tell me what is happening in the first case. What is this? Reduction or oxidation?
Reduction.
Why reduction? Tell me.
Because it
Mhm,
has K. It has K plus
mhm. And
and K.
no, थोड़ा सा और उसको rephrase कीजिए अच्छे से बोलिए. If something is a process, we like if something is a process and we identify this process from initial and final stage, then we use the word change, right? So what change is happening? Talk in that term. Yes,
So
Rifat?
I don't know how to phrase it.
No. You have to know how to phrase this, right? दो चीजें हैं आपके पास. इनिशियल क्या है आपके पास, बताइए. पहले क्या है आपके पास?
K plus.
K plus. और फाइनल क्या है आपके पास?
K.
K. So K plus is dash to K is
Reduction.
K plus is, हम ऐसे बोल रहे हैं K plus is dash to K. क्या हो रहा है? K plus is English सिर्फ और सिर्फ English. K plus is
K plus is gaining an electron.
नहीं, गेनिंग इलेक्ट्रॉन केमिस्ट्री हो गया. इंग्लिश हमको चाहिए. हमने 5 साल के बच्चे को बोला, पहले K plus था, एक बक्से के अंदर गया, बाहर निकला तो K हो गया. बताओ क्या हो रहा है? How will he phrase it? Tell me. K plus is sorry.
K plus is losing the.
अब लूजिंग इलेक्ट्रॉन तो फिर केमिस्ट्री आ गया ना. 5 साल के बच्चों को केमिस्ट्री क्या पता?
हाँ.
Sorry. How?
K
What
plus,
you are? K
K
plus
plus
is
loses the plus.
हाँ ठीक है. या फिर और क्या बोल सकते हैं? प्लस लूज कर रहा है, तो इससे भी आपको पता चल रहा ना कि यहाँ पे इसका क्या था. अब देखिए केमिस्ट्री आएगा तो यहाँ पे इसके पास प्लस था, अब यहाँ पे डिक्रीज होके कुछ नहीं है, तो देयर इज अ डिक्रीज इन ऑक्सीडेशन स्टेट. कैन से K plus is changing to K.
Yes.
Right? K plus is changing to K. ठीक है. And that is right as what? Oxidation या reduction?
Reduction.
Reduction. What about here? Ag plus to Ag?
Reduction.
What about here? Hg2 plus to Hg?
Reduction.
Mg2 plus to Mg?
Reduction.
Cr3 plus to Cr?
Reduction.
Reduction. Very good. All of these are what? All of these are reduction. Yes, Nawal?
Yes, sir.
Okay, fine. Now, all of these are reduction. Now tell me the reduction which are spontaneous. Spontaneous reduction. कहाँ पे हो रहा है?
Ag.
Ag plus to Ag. पूरा बोलिए. Ag plus to
Ag plus to Ag.
Ag. And where else?
Hg2 plus to Hg.
Hg2 plus to Hg. Nawal आपको दिख रहा था? Yes or no? Tell me.
Yes, sir.
Okay. Now, the others are non-spontaneous reduction. Yes or no? उनका रिडक्शन
Yes.
कैसा है? नॉन स्पॉन्टेनियस है। तो ऑक्सीडेशन कैसा होगा उनका? अगर रिडक्शन नॉन स्पॉन्टेनियस है तो ऑक्सीडेशन कैसा होगा?
Spontaneous.
स्पॉन्टेनियस हो जाएगा, राइट? सो नाउ यू आर गोइंग टू टेल मी स्पॉन्टेनियस ऑक्सीडेशन। बताइए किस किस का स्पॉन्टेनियस ऑक्सीडेशन होगा?
K plus to K.
हाँ, जैसे ही हमने ये लिखा K+2K, हम लोग क्या लिख रहे हैं? ऑक्सीडेशन लिख रहे हैं या फिर रिडक्शन लिख रहे हैं? बताइए, व्हाट आर यू राइटिंग?
Reduction.
वी आर राइटिंग रिडक्शन। तो हम लोग को रिवर्स करना पड़ेगा। दिख रहा है आप लोग को हाउ टू प्ले,
Yes.
राइट? ओके, यू शुड बी कंफर्टेबल विद दीज थिंग्स, ओके? नेक्स्ट बोलिए, स्पॉन्टेनियस ऑक्सीडेशन कहाँ हो रहा है? और
Mg
Mg
to
to
Mg.
Mg, okay. Where else? Is there anything else जहाँ पे spontaneous oxidation हो रहा हो?
Cr3 plus to Cr.
एक सेकंड, हमने इसको फिर से वापस से वैसे ही लिख दिया। आई थिंक इट विल बी लाइक दिस ना, K2K+, ऐसे लिखेंगे ना? इज नो?
Yes.
अच्छा, इसका ये कितना हो जाएगा? ऑक्सीडेशन कितना हो जाएगा इसका? बताइए। K+2K में हम लोग को तो इलेक्ट्रिसिटी मिलेगी, यस नवाज? यू विल गेट इलेक्ट्रिसिटी। विल वी गेट इलेक्ट्रिसिटी? नहीं सुनाई देता आप लोग, प्लीज थोड़ा माइक ऑन ठीक से किया कीजिए, 10 बार पूछना पड़ जाता है आप लोगों से। विल वी गेट इलेक्ट्रिसिटी
Yes,
व्हेन
sir.
K इज ओके? हाउ मेनी वोल्ट्स?
Plus 2.92.
वेरी गुड। नवाल, आपको दिख रहा है? नहीं दिख रहा? नहीं दिख रहा आपको?
Yes, sir.
तो फिर बोल क्यों नहीं रही हैं आप? ओके, नेक्स्ट टेल मी। K से K+ था, उसके बाद आपने वो नहीं क्या बताया था? बताइए फिर से। स्पॉन्टेनियस ऑक्सीडेशन
Mg to
Mg
Mg to
Mg.
Mg to Mg2+ बोलिएगा, ओके नवाल? ऑक्सीडेशन बोल रहे हैं ना? हाँ नवाल, यू टेल मी हाउ मेनी वोल्ट्स ऑफ इलेक्ट्रिसिटी विल वी गेट बाय दिस रिएक्शन?
Plus 2.37.
+2.37 वोल्ट्स। और जब हम लोग करेंगे नेक्स्ट, टेल मी व्हाट इज द नेक्स्ट वन? स्पॉन्टेनियस ऑक्सीडेशन और कहाँ हो रहा है?
Cr to Cr3.
Very good. Cr2 Cr3+. And how much electricity are we going to get?
Plus 0.74.
Plus 0.74 volts. Very good. अच्छा, यहाँ पे Ag के लिए भी लिख देते हैं हम लोग। Ag we are going to get 0.80 volts of energy, and from Heg2+ we are going to get 0.79 volts of energy. Okay, fine. So अब ये बताइए आप लोग, if I make a cell like this, let's suppose we have a cell in which I have K2K+. In anode I have a bridge, and my cathode is going to be Ag+2 Ag. So this whole cell will give me how much electricity? Please tell me. E0 cell will be how much?
E
E cathode.
E cathode minus E anode.
फिर से आप लोग वही E कैथोड माइनस E एनोड, ये भूलिएगा नहीं आप लोग। देखिए बहुत ही सिंपल है, ठीक है? मेक्स आप लोग को वो समझ में आता है E कैथोड माइनस E एनोड? हाँ नवाल, या फिर
Yes.
समझ में आता है?
Yes, sir.
हाँ, टेल मी, एक्सप्लेन दैट टू मी। E cathode minus E anode. Why is it not E anode minus E cathode? Yes, Nawal. Why is it not the other way around, or Rifat? Both of you said the same answer. E cathode minus E anode. Tell me, why is it not the other way around?
So because in the reaction, it the anode reduce. No.
think and देखिए there is a reason. ये सही है, हम नहीं बोल रहे कि गलत है ये, ठीक है, this is fine, this is correct, but you should also understand it. Why is it right? I will देखिए हम अभी इसको ना एक्सप्लेन नहीं करना चाहते, ठीक है, बिकॉज देर इज अ बिट ऑफ जगलरी हियर, ठीक है, व्हाट इज जगलिंग ऑफ थिंग्स. और पहले से ही व्हेन यू सी इलेक्ट्रोड पोटेंशियल, ऑक्सीडेशन रिडक्शन, इन ऑक्सीडेशन गेन, है ना, ऑन ऑक्सीडेशन गेन ऑफ ऑक्सीडेशन स्टेट एंड लॉस ऑफ इलेक्ट्रॉन, ठीक है, प्लस माइनस साइन, उसी में बच्चे कंफ्यूज होते हैं. दैट इज व्हाई व्हाट आई से इट इज वेरी सिंपल, ठीक है. आपको ये फॉर्मूले की जरूरत नहीं है. आप ये सोचिए ना कि स्टार्टिंग में फॉर्मूले की क्या जरूरत है. जब हम लोग के से के प्लस जा रहे हैं तो हमको कितनी एनर्जी मिल रही है, कितना इलेक्ट्रिसिटी मिल रहा है, बताइए. व्हेन आई एम गोइंग फ्रॉम के टू के प्लस, हाउ मच इलेक्ट्रिसिटी आई एम गेटिंग, टेल मी, हाउ मच इलेक्ट्रिसिटी एम आई गेटिंग?
-2.9.
के टू के प्लस, के टू के प्लस में कितना इलेक्ट्रिसिटी मिल रहा है हमको?
+2.9.
प्लस 2.93. और एजी प्लस से एजी में कितना इलेक्ट्रिसिटी, दोनों से तो हमको इलेक्ट्रिसिटी मिल रही है ना. सो आई विल राइट प्लस, हाउ मच इलेक्ट्रिसिटी एम आई गोइंग टू गेट फ्रॉम एजी टू एजी प्लस?
0.80.
0.80. अब ये चीज आप किसी को भी समझा सकते हैं कि नहीं समझा सकते, बताइए.
Yes.
Right, and what we have done here, this is E naught of oxidation plus E naught of reduction. Okay, plus E naught of reduction. Now, even if there is, आपको लगेगा कि सर आप बहुत सिंपल केस ले रहे हैं, दोनों में प्लस है. हम लोगों ने स्कूल में क्या था, उसमें एक में माइनस भी आता था, कुछ भी हो जाता था उसमें, तो आप तो बहुत आसान सा केस ले रहे हैं. हम लोग ठीक, नो प्रॉब्लम. My formula is what you have to think. What is the most natural thing is that whatever oxidation is happening, if it is giving me electricity, I will add that, right? If it is giving me electricity, I will add that. From reduction also, if I am getting electricity, I will add both of those electricity. Yes or no? Please tell me. Nawal and Rifat. Plain logic.
Yes.
Plain logic. Okay, I'm going from plain logic. बिल्कुल ठीक है. अब हम बनाते हैं कुछ थोड़ा दूसरा टाइप का सेल, ठीक है. What I'm going to make, I will say that if I choose, like I don't have Ag, silver, very expensive. Mercury, I don't know how to have a mercury electrode because it is liquid. So what do I have here? I have potassium and I have chromium. I have potassium and I have chromium. Now you tell me which of them is going to be having, which of them has higher oxidation potential? Potassium or chromium, which has higher oxidation potential? Tell me. Which has higher oxidation potential?
Sir, can you repeat? I could not hear.
Okay, fine. I'm saying that, let us suppose I don't have Ag. It's very expensive. I don't have Hg because I don't know how to convert it into solid state, because mercury is going to be liquid in room temperature. So I don't have these cells, for example. Okay, I don't have these cells. I only have these half cells. These are half cells now. These half cells I don't have now. I have only these half cells. Okay, I have only these half cells and I have to work from this half cell. Now I am choosing potassium. I'm choosing potassium and I'm choosing chromium. Okay. I have to make a cell using potassium and chromium. I have to make a cell using what? Tell me. I have to make a cell using potassium and chromium. Very good. Potassium and chromium. Now, whenever I have to make a cell, I have to choose two things. I have to choose an anode and I have to choose a cathode. You're with me, guys? Did you know? Please tell me, Nawal and Rifat.
Yes.
Yes.
Right? Okay, fine. Now, what will be the anode? Anode will be anything that is having higher oxidation potential. Yes or no? I have to compare all this, right? If I have taken two things, for example, potassium and chromium, and I have to choose an anode, then anode will be that thing which is having higher oxidation potential. Tell me, which is having higher oxidation potential, potassium or chromium?
Potassium.
Potassium is having higher,
Higher.
higher, है ना? ठीक है. And cathode में I will say whatever is having higher reduction potential out of these two things. Or rather than saying higher reduction potential, I can also say which is having lower oxidation potential. Make sense? Yes or no? Please tell me. Both are same thing?
Yes, sir.
Okay, fine. Now I will make an anode from K plus. So for K plus, I will write K to K plus. And for cathode, I'm not going to write this part. I'm going to write the reverse, because cathode, Cr3 positive to Cr. Makes sense till here? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
Makes sense? Okay, fine. Very good. Now I'm going to use the same thing here. the E naught of cell. Now, K to K plus, it is giving me electricity, yes or no? Please tell me. Is it
Yes.
giving me electricity? How many? How
Yes.
much volts? How much volts? How many volts?
2.9.
2.93. 2.93. Very good. Now, this is like this, E naught oxidation plus whatever the E naught of reduction is. Now tell me, Cr3 plus to Cr, is it giving me electricity or it needs electricity? Cr3 plus to Cr
Yes.
needs electricity. How much? Tell me.
0.7.
Minus
0.
0.6.
Correct. Now, because it is taking electricity, it will be minus 0.74. Makes sense, Nawal? Yes or no? Please tell me. Cr3
Yes,
plus to
sir.
Cr. Okay. Now you can just calculate. As simple as that. 2.93 minus 0.74. Yes or no?
Yes, sir.
Okay. So whatever electricity is given or it is needed by this reaction plus whatever electricity is given or needed by this reaction, E naught oxidation plus E naught reduction. E naught oxidation plus E naught reduction. And E naught oxidation of whom? Of the anode. E naught reduction of whom? Of the cathode. Okay. So that is going to be a very simple framework for you to remember it. Okay. Anode and cathode. Anode का oxidation plus cathode का reduction. That's it. It is not wrong, okay? ये मत सोचिए कि हम कुछ और बता रहे हैं और आप लोग को मार्क्स नहीं मिलेंगे स्कूल में. You will get marks. This is completely right. It is and above that it is logical. Okay, above that it is logical. Now, right here, what we have written, the last point, galvanic cell consists of two half cells. The half cell having the higher reduction potential behaves as the cathode. The half cell having higher oxidation potential will act as anode. Okay, and that's what we have learned now. That's what we have learned now. Now you write here EMF or cell potential. EMF or cell potential. Rather, EMF is capital. Oops, sorry. EMF or cell potential. Right here, first of all, the potential difference between two electrodes when no current is drawn from it. When no current is drawn from it. Okay, we are not using the current, है ना? That potential difference. I'll write some remarks. Right here, EMF is defined as sum of electrode potential of oxidation half cell, oxidation and reduction. Oxidation and reduction half cells. Okay, now that means E cell or rather E naught cell, this will be equal to the E naught of oxidation. Okay, E naught of oxidation of what? Of the anode, plus the E naught reduction of cathode. And if I have just E cell, then E cell will be equal to E of oxidation of the anode plus E reduction of the cathode. The naught sign, just I hope you have written about the naught sign also. No, E naught is what? It is the standard electrode potential. Okay, E naught is the standard electrode potential. Okay, now I will tell you where that term comes from. E naught cell is equal to E naught cathode minus E naught anode that you have learned. Okay, now you see here, since, right, the next point, since the reduction potential is called electrode potential according to IUPAC. देखिए, please remember this, electrode potential are always two. electrode potential क्या हो सकते हैं? ऑक्सीडेशन भी, रिडक्शन भी, कुछ भी ले सकता था IUPAC, लेकिन IUPAC ने क्या लिया है? रिडक्शन पोटेंशियल को लिया है. And also I have explained it why they have taken reduction potential as the electrode potential. ठीक है, they have to choose either from oxidation reduction, किसको लेना है, क्योंकि both of them have some relation, right? Oxidation potential is what? It is just the negative of the reduction potential or vice versa. अगर आपके पास 0.79 है oxidation potential, तो minus 0.79 reduction potential होगा. Okay, now what we are going to see, we are going to take the E naught reduction of both the things. E naught reduction of both the things. अब देखिए, now E naught cell, this will be equal to, ये E naught क्या है? What is this E naught? Oxidation है? Yes or no? Please tell me. This is E naught oxidation.
Yes,
तो इसका E naught reduction हम कैसे लिख सकते हैं? माइनस E naught. एनोड का कोई दिक्कत? Same thing I have written the same thing. Yes or no? Please tell me.
yes,
Yes.
Right? Plus E naught reduction. अब हम सिर्फ रिडक्शन ले रहे हैं क्योंकि आईयूपैक बोल दिया कैथोड. ठीक है, तो अब आप लोग यहाँ पे दिख रहा है why it is E naught of anode, sorry, E naught of cathode minus E naught of anode. Now can you explain this one also? Tell me guys, can you explain this one also? Why is it like that?
Yes, sir.
है ना? Try to talk about these things like on your head only, okay, when you are learning things and all. अब आपकी मर्जी है, ठीक है, आपकी मर्जी है. Like what I like is this one, because I don't have to actually worry about the minus sign. Like cathode minus anode, anode minus cathode. I always had some problem with memorizing thing. So that is why I sat down one day and just figured it out in my 12th standard. ये negative है क्यों? Why is this negative? Why is it not the other way around? And the simple explanation that I came up with is that जिसका ऑक्सीडेशन हो रहा है वो कितना वोल्ट एनर्जी दे रहा है, जिसका रिडक्शन हो रहा है वो कितना वोल्ट एनर्जी देना है, दोनों को ऐड कर दीजिए. जब ऐड करके देखा तो आंसर सेम आने लगे. And when the answers came same, then I thought, okay, fine, they have taken the reduction potential record, because books also do not explain, because they have just stated that in a reduction लेते हैं. IV पैक के मुताबिक. So they have just taken the E0 of reduction. Both of these E0 are what? This is also the reduction potential and this is also the reduction potential. ये चीज ध्यान में रखिएगा. Okay. Done everyone? Yes or no? Please tell me.
Yes, sir.
Yes.
Okay. चलिए अब आप लोग को ना एक एक्सरसाइज देते हैं जो थोड़ा सा फन होगा, थोड़ा सा आप लोग के दिमाग में बोझ डालेगा. आप लोगों ने अभी देखा, लाइक ऑल ऑफ यू सॉ दैट even though CR वाला डिलीट कर दिया क्या हमने? नहीं, हाँ ये तो है. Even though this is not spontaneous, correct? Yes or no? Please tell me. CR3 plus 2 CR was not spontaneous, right?
Yes.
Yes.
But still we can use it. And this value is going to be positive, right? Minus 2.93. Sorry, 2.93 minus 0.74. It will be how much? Tell me. Minus 0.74. It will be 2.19. Correct? Yes or no?
Yes.
By the way, how do you guys? देखिए अभी ना थोड़ा सा मैथ आप लोग को बता देते हैं. जैसे इस बार 2.93, तो इसको हम क्या लिख सकते हैं? 293 लिख सकते हैं. And what do we have? 74. Correct? Yes or no? Tell me.
Yes.
ये भी बताइए. 29 minus 7 कितना होगा? 29 minus 7. 29 minus 7 कितना होगा?
22.
22. और 3 minus 4?
-1.
Minus 1. अब ये बताइए ये क्या है? ये एक्चुअली तो हमने ये किया ना 290 और यहाँ पे हमने 70 माइनस किया. तो आपको क्या बचेगा? यहाँ पे 220 बचेगा. 220 minus 1. I hope you can figure this out at 220. Yes or no? Please tell me.
Yes.
Yes.
220 minus 1. 220 minus 1.
290.
290.
290. ठीक है. तो बोरिंग का चक्कर हटाइए अब. ठीक है. प्लीज डोंट बोरो करने पे आपको मिस्टेक्स के ज्यादा यहाँ पे चांसेस रहेंगे. ठीक है. सो व्हेनेवर यू हैव समथिंग लाइक दिस विल राइट जैसे आपके 2 डिजिट. और आप देख लीजिए एग्जांपल यू हैव समथिंग लाइक दिस 153 माइनस लेट अस से 76. ठीक है. 15 minus 7. 15 minus 7
8.
आप 8 ही लिखिएगा. ठीक है. क्योंकि हम लोग टेंस में बात कर रहे हैं. एंड 3 minus 6
3. -3.
minus 3. 80 minus 3. 80 minus 3.
77.
77. ठीक है. I hope it will make life a bit easier. Okay, so now what you have to do? I'm giving you some time. So these are the अच्छा एक काम कर. These are the electrode potential. ठीक है जो आपके पास है. These are the electrode potential. You have to make cells. ठीक है. That give you positive electricity. Those are working cells जिसमें negative नहीं आना चाहिए. For example, I cannot have a cell in which I can use. If I use, let us say for example, Hg2 plus, ठीक है, in the anode, and I'm using K plus in the cathode. So this is going to give me minus 0.79. Yes or no? Correct.
Yes.
And what about K to K plus? It is going to give me
2.
नहीं, ये तो उल्टा नहीं, वेट, ये उल्टा हो गया ना. तो यहाँ पे K plus 2K लिखना चाहिए था because it is cathode. K plus 2K will give me how much? K plus 2 minus 2.93. तो ये सेल वर्क करेगा? कैन आई कॉल इट अ सेल? सेल मतलब बैटरी होता है. ये तो इलेक्ट्रिसिटी ले रहा है ना. It is not giving me electricity. This whole cell is taking electricity. Can you see that? Yes or no? Please tell me.
Yes.
Right. So this type of cell you don't have to make, but you have to combine and make all the possible cells. Make all the possible cells which are possible. है ना? Make all the possible cells. Make all possible cells and calculate their E नॉट सेल। मेक ऑल का मतलब आपको सेल रिप्रेजेंटेशन से करना है, ठीक है, सेल रिप्रेजेंटेशन से। एंड एक और चीज कर देते हैं, एंड शो द रिएक्शन एट एनोड एंड कैथोड। ठीक है, हम एक कर दें क्या आप लोगों के लिए, बताइए। हनीफा, नवाल, हनीफा तो
Yes,
अभी आएंगे,
sir.
हनीफा अभी नहीं कर, एक कर दें आप लोगों के लिए। अच्छा ठीक है, हम पहले आप ही लोग कीजिए ना, एक मेटल चूज कीजिए।
के
सॉरी,
के
क्यू,
पोटेशियम
पोटेशियम, के, ओके, पोटेशियम, एंड देन चूज अनदर, चूज समथिंग एल्स। दो तो चूज करने होंगे ना आपको सबसे पहले, एक और चूज कीजिए।
Mg
Mg। अब इस जैसे आपने चूज कर लिया, नाउ यू आस्क योरसेल्फ व्हिच इज हैविंग हायर ऑक्सीडेशन पोटेंशियल, बताइए व्हिच इज हैविंग हायर ऑक्सीडेशन पोटेंशियल।
K
Okay, so K will be anode or cathode?
anode
Very good. So we'll have K to K plus bridge. Mg will be anode or cathode.
cathode
So how will I write the reaction? How will I write the representation?
Mg2 plus 2Mg
Mg2 plus 2 Mg. Very good, है ना? Cell representation हो गया। अब ये बताइए what is how much energy am I getting or it is requiring? What is the electricity change K to K plus? How much electricity is it giving to me? It is giving me how much electricity? K to K plus
2.93
yeah plus 2.93. What about Mg to Mg2 plus 2 Mg? How much electricity is this giving? Nawal, tell me. Wait a second. Nawal, this is giving me how much electricity?
Minus 2.37.
Very good. Minus 2.37. Oops, sorry. So E naught cell will be equal to how much? Tell me.
minus 2.37 plus 2.9 sorry minus 2.37 minus 2.9
क्यों माइनस माइनस कर रहे हैं आप लोग? हमने तो इतना, इसीलिए हमने इतना सिंपल सा आपको बताया था ना। क्या बताया हमने आपको? दिस इज गिविंग मी हाउ मच, और ये हमको कितना दे रहा है, दोनों को ऐड कर दीजिए बस। हम तो एक का ऑक्सीडेशन ले रहे हैं, दूसरा का रिडक्शन ले रहे हैं ना। कैन यू सी दैट? यस और नो, प्लीज टेल मी।
yes
है ना, दैट इज वाई आई से दैट वो रिडक्शन कैथोड माइनस एनोड वाला कभी मेक सेंस करेगा ही नहीं, क्योंकि यहाँ पे ऑक्सीडेशन हो रहा है और वो बोलता है रिडक्शन पोटेंशियल लेने के लिए। राइट, इन द इक्वेशन दे से दैट टेक द रिडक्शन पोटेंशियल फॉर बोथ द थिंग्स। कितना चीज याद रखे आदमी, कितनी चीज याद रखे, जो चीज लिखा हुआ वो चीज करिए। इसका ऑक्सीडेशन, इसका रिडक्शन, दोनों को ऐड कर दीजिए। कितना आएगा बताइए? व्हाट शुड आई राइट हियर, प्लीज टेल मी। What should I write here?
0.56.
0.56। आर यू श्योर? हाँ ठीक है, 5.6। हाँ ठीक है, तो सेल काम करेगा या नहीं करेगा बताइए?
it will work
It will work, right? Because it is giving me electricity. We can call it a cell. Nawal, you got it? Yes or no? Please tell me.
Yes, sir.
Okay. Now, how will I write the anode? What is happening in anode? Tell me. Please tell the reaction.
Oxidation.
ऑक्सीडेशन हो रहा है, रिएक्शन स्पेसिफिक बता दीजिए इस सेल के लिए। क्या रिएक्शन हो रहा है, क्या ऑक्सीडेशन हो रहा है, किसका ऑक्सीडेशन हो रहा है? अरे
K.
पूरा बताइए, एक एक चीज हम नहीं पूछेंगे। के कितना इलेक्ट्रॉन ले रहा है, पूरा
K
बताइए। हाँ,
gives
के गिव्स, वेरी गुड,
K plus 2 E
प्लस 2 इलेक्ट्रॉन। अरे एक इलेक्ट्रॉन ना भाई, यहाँ पे एक चार्ज
yes
आ रहा है तो एक इलेक्ट्रॉन निकलेगा ना जी, बहुत बढ़िया।
yes
कैथोड के लिए बताइए, व्हाट इज हैपनिंग इन कैथोड?
M Mg2
नवाल,
plus
नहीं नवाल बताइए, नवाल तो बिल्कुल शांत हो जाती है। नवाल बताइए।
Mg plus 2E gives Mg.
mg
Plus
mg
2 electrons gives
mg
Mg.
Mg2 plus 2 इलेक्ट्रॉन, है ना?
Yes.
ठीक है, गिव्स Mg। अब हमको यहाँ पे सेल रिएक्शन भी लिखना होगा। Okay, now what did I say? Whenever I'm going to write the cell reaction, I have to balance the equations, balance the balance the electron number. Okay, number of electrons should be same. I will multiply 2 here. If I will multiply here, I will get 2 electron, 2k plus, and 2 here also. Now I can eliminate the electrons like this, and you can write the equation as 2k plus Mg2 plus is going to give me 2k plus Mg. Makes sense? Yes or no? Please tell me.
Yes, sir.
Yes. Now please. क्या किया सबसे पहले आपने? चूज एनी टू जिसका ऑक्सीडेशन पोटेंशियल ज्यादा है तो वो ऑक्सीडेशन हो जाएगा। अगर आपने रिडक्शन का लिया तो जिसका रिडक्शन पोटेंशियल ज्यादा है वो रिडक्शन में चला जाएगा। ठीक है, चलिए, दिस इज द क्वेश्चन, प्लीज राइट इट डाउन। So after 10 minutes, you are going to send me some answers. Okay, at least by 10 minutes, you should have some answers. Acha, guys, did you write this thing down? Tell me, spontaneous reduction, spontaneous oxidation.
Yes.
What about Hanifa
Yes,
and
sir.
others? Wrote it? All of you wrote it, now?
Yes.
Okay, fine. So I will stop sharing the screen for a while so that you can do it. Okay, and I will meanwhile do all the possibilities here. Okay, fine. So let me stop sharing the screen here. आप खुद से try कीजिए। 10 मिनट के बाद you will send me the answers, whatever you have done. Okay, if you get stuck, you can ask me. Okay, if you get stuck, you can ask me. Okay, so start sending the answers now. What happened, guys? Start sending the answers.
Yes.
So,
Yeah, tell me.
so for the first one we did the potassium and the magnesium one. Can you tell me why did we multiply by 2 for the anode?
Can we do what? Can we?
For the anode, we multiplied it by 2. Why did we do that?
So when we are writing a cell reaction, the cell reaction does not contain any electrons. So in order to remove the electrons, that means in order to cancel the electrons, because if you remember the first class, whatever electron is coming from anode, it is going to the cathode and it is getting reacted. Yes or no?
Yeah.
Okay, so that is why we have to balance those number of electrons. Anna? Got it?
Okay.
Okay, so we have, so that the cell reaction, it does not contain any electron. Okay, so Rifat made, okay, so Mg and chromium is the, okay, fine, you have made a new one. Fine. ठीक है, correct. Okay. So, Rifat, you have to send me the answer. Nobody else sent me the answer. So I think you multiplied by 3 also. And okay, fine. I think those numbers are also correct. Let me just recheck 2 point. Yeah, those numbers are also correct. Okay. Hanifa, you will understand it better if you watch the lecture actually. Okay.
So I tried one, but I'm not sure if I'm correct.
नहीं आप भेजिए. Okay, you send it. You send it. एकदम सही है. Hanifa, like till E0 cell it is fine. tell me. Okay, for anode, what reaction is happening at anode? Tell me. Yes, Hanifa. For Mg2 plus 1, बताइए.
Mg2 plus and then 2 electrons.
नहीं तो वो रिडक्शन हो जाएगा ना. क्या हो रहा है एनोड में? क्या होता है? व्हाट हैपेंस इन एनोड? ऑक्सीडेशन happens in anode, है ना. Mg2, see, you have written also that, na? Can you see that you have written
Yes.
Mg2 Mg2 plus, right? That is
Yes.
correct. Plus 2 electron. And in cathode, what is happening?
Reduction.
So what will be the reaction?
Cr3 plus minus.
Plus 3 electrons, right? Gains electron, na?
Yes.
It is going to give you Cr, correct?
Mm.
How will we balance this number of electrons? What do you think? What should we do?
We can
multiply. I mean, we can multiply on both the equations. Okay. Think in those terms. What should I multiply in the first equation? What should I multiply in the second equation?
3 and 2.
3 in the first one or the second one?
3 in the first one and 2 in the second one.
Very good. So you'll get this as 6, right? You'll get this as 6, 6, and 6, right? So we'll write here 6 Mg plus 6 Cr3 positive is going to give me Mg2 plus 6 Cr3 positive. Sorry, 6 Cr. Correct? Yes or no?
Yes.
Oh, wait a second. यहाँ एक सेकंड हमने सब जगह 6 ही लिख दिया. वेट अ सेकंड. सिर्फ इलेक्ट्रॉन्स में 6 होगा, राइट? द इलेक्ट्रॉन विल गेट कन्वर्टेड टू 6. माय बैड ना, सब में 6 नहीं होगा. विल हैव 3 Mg, right, Hanifa?
Yes.
You saw where I got wrong?
Yes.
2 here and 2 here. Okay, so the 6 electrons will be cancelled. The other thing, this is 3 Mg plus, and this is 3 Mg, and this is 2, and this is 3, and this is 2. Okay. So also I will try to get this lecture uploaded, I mean today itself, so that you can watch it tomorrow. Okay. And next thing that I want to give you as a homework, all of you, please write it to your notebook. Okay. I mean, I have talked about the salt bridge in the first lesson only, but I did not write anything about the salt bridge. So you write a question. What is a salt bridge? And what are its function? Okay. So basically, when you are going to write this down from anywhere, you can refer NCERT textbook. If you have any of the lecture notes from your school, you will write it down and then you will send it to me on WhatsApp. Okay, so send it to me on WhatsApp, and this should be in your notes as a question and as an answer. Okay. And we can tell me.
This was in the assignment yesterday.
हाँ, तो जनरली होता है कि सारे बच्चे तो नहीं लिखते ना असाइनमेंट. आपने लिखा है?
What is for what is salt bridge? Can we just write it is the salt?
It is
a circuit we used to complete. No.
नहीं नहीं
This-
ऐसे लिखते हैं, सॉल्ट ब्रिज होता है ना, सॉल्ट ब्रिज इज अ इन्वर्टेड यू टाइप, इन्वर्टेड यू शेप्ड ट्यूब, ठीक है, दैट इज अ सॉल्ट ब्रिज। क्या है वो? सबसे पहले इन्वर्टेड यू टाइप ट्यूब containing saturated solution of inert electrolyte in the form of agar-agar solution. Okay, let me write that down. Is right. हम ये लिख देते हैं definition salt bridge का, और बाकी चीजें आप functions आप लोग लिखिएगा, ठीक है? If you don't understand the function, then you will tell me, because you have already explained what are the functions and why you are using starting से बिल्कुल. Is right. It is defined as salt bridge. Salt bridge is an inverted U-type tube containing saturated solution of inert electrolyte in the form of agar-agar solution. अगर अगर क्या होता है? अगर अगर आप पूछते नहीं है आप लोग, है ना, पता है अगर अगर क्या होता है? व्हाट इज अगर अगर? हाँ तो फिर पूछिएगा, सिंपली उसको आप समझिए दैट इट इज सेमी लिक्विड टाइप का, तो पेस्ट टाइप का होता है ना, उसको अगर अगर बोलते हैं, दैट्स इट। ओके, सो कीप अ हैबिट ऑफ आस्किंग दीस टाइप ऑफ क्वेश्चन, जो भी आपको नया वर्ड मिला, ठीक है ना, इसी वजह से वो ई नॉट कैथोड माइनस ई नॉट एनोड वाला आप लोगों को क्लियर नहीं रहता, मतलब किसी बच्चे को भी क्लियर नहीं रहता वो चीज। सेमी लिक्विड सोल्यूशन होता है, ठीक है। यू कैन राइट द फंक्शंस। आई होप यू रिमेंबर द एक जो फंक्शन जो बहुत ही इंपॉर्टेंट था, दैट वाज द इलेक्ट्रिकल न्यूट्रलिटी। देन यू मस्ट आल्सो नो दैट इट आल्सो completes the external circuit of the completes the external circuit of the cell, right? Yes or no? Tell me.
Yes.
ठीक है, so these are the two main functions. Now we'll do one thing, small thing, that is known as Nernst equation. Okay, we'll do one thing that is known as Nernst equation. Now I will not teach anything like extra in the Nernst equation, या फिर उसके जो examples हैं, या फिर उसके जो problems हैं, numericals हैं, those portion I am not going to teach now, but I am going to just give you an idea about the Nernst equation. Okay, about the Nernst equation. So before the Nernst equation, rather I have to teach you guys. Chal, theek hai, so we'll meet in the next class only, because before the Nernst equation, I think I should teach you guys that electrochemical series and how to remember the electrochemical series. That is more important, I think. And then we will understand the Nernst equation in the next class only. Okay. So we'll meet tomorrow. We'll start with electrochemical series. And I will also give you a trick to remember the electrochemical series, how to remember it. Okay, and then we will also do the application of electrochemical series. Then only we can start Nernst equation, not right now. Okay, chali. Thank you guys. Please write that salt bridge one.